All right, let's look at question 8. See what we want to optimize here. So two vertical poles of different heights stand on level ground. So let's do some more bad art just to kind of organize what we're doing here. So one post and then a shorter post. I know this distance is 100 feet. I know this height is 80 feet. This height is 60 feet. And I have a cable stretched from the top of one pole to some point on the ground between the poles. And then to the top of the other pole. Okay. And then I want to know what is the minimum possible length of cable required. Okay, so minimum length, that's a good idea of, that's a good indicator. That's the thing, that's my objective function. That's what I want to minimize. So what is that? That's a length. So what's a good, how can I think about this length? So let's break this length into two pieces here. How do I find the length of this first piece of cable? So the one that goes from the top of this first tower or this pole to the ground. So I think I'm going to have to use Pythagorean theorem here. So let's do this. Let's do length one. It's going to be 80 squared plus what? What is, so 80 is definitely that vertical distance, but what's the horizontal distance from the base of the left pole to the point on the ground where this cable is anchored? I don't know that. And in fact, I think that's going to be my variable. So I'm going to call that x. So if that's x, so 80 squared plus x squared equals, actually, okay, that's, I think the square root of this is what the length is. So by Pythagorean theorem. Now can I do the same thing for length 2? So let's label these length 1, length 2. So the vertical height here is given to us. That is 60 squared plus what? I'll call this other one y. So this other horizontal distance I'll say is y. So 60 squared plus y squared. So now here's what I think I have. I think I have length 1 plus length 2 equals those two radicals there. So let's say this. My length in terms of x and y is equal to the square root of 80 squared plus x squared plus the square root of 60 squared plus y squared. So I have an objective function in terms of x and y. I would really like to have an objective function in terms of only one of those. So how do I get there? What's my constraint here? What's the requirement I need to fulfill? I think, well, let's take a look at it more basically. Do I have any way to know how x and y are related? And I think in this case, what do we know about x and y? We know that x and y are, they sum to 100. We know that x plus y equals 100. So because of that, I know that basically I can use this to get my objective function down to a single variable. I think I've shown preference to x so far, so let's go the opposite way this time. I'm going to solve for x. So x equals 100 minus y. What does that help me to do with my function? So now my length is going to be a function in y only. So length as a function of y only is going to be the square root of 80 squared. Let's stop here at 80 squared. 80 squared is 6,400 plus 100 minus y squared plus the square root of 60 squared, which is 3,600 plus y squared. So here's something that you may not have done, and that's okay, but I really don't want to differentiate the square root because then I have to use chain rule and I just don't want to do it. So let's do this. I'm going to square. Actually, I can't do that now, can I? Nope, squaring both sides is going to make this even more nasty. Okay, so let's just go ahead and differentiate normally. Actually, I can do one more thing here. I can evaluate once more inside this first radical. So the square root of 6,400, and then I'm going to square this binomial. So plus 100 squared, which is 10,000, minus 200y plus y squared plus the square root of 3,600 plus y squared. So does that radical simplify for me at all? So L of y equals the square root of 164,000. No, 16,400 minus 200y plus y squared plus the square root of 3,600 plus y squared. So I have an objective function. So to progress from here, I am going to take a derivative of this with respect to y. And this is going to have to involve chain rule because I have these square roots. So off to the side here, I will remind us what the derivative of a square root is. So the derivative of x to the 1/2 is 1/2 x to the negative 1/2, or 1/2 radical x. So that means this derivative is going to be 1/2 times the radical 16,400 minus 200y plus y squared, multiplied then by the derivative, or yeah, the derivative of the inside function. So what is the derivative of the inside function? That'll be minus 200 plus 2y. Plus, again, so the derivative of this is going to be 1/2 times the derivative of 3,600 plus y squared times the derivative of the inside, which is going to be 2y. And I want to set that equal to 0. So this is a derivative that I think would be a little bit difficult to evaluate by hand because I think probably most direct route here is going to be to evaluate this by first finding common denominator. So I am instead going to let Desmos do the hard work for me. So let's do this. So first, let me type this out, and then I can actually just go with the original function, then we'll deal with the derivative of that. So the function is the square root of 6,400 plus 100 minus x. Okay, so let's go ahead and drag this over now that I have it. All right, so here's my function. I believe I have a minimum here, so that minimum comes at y equals 42.857. So let's go back to our drawing here. So go ahead and go again. So we said that our y value was equal to, so we'll use Desmos to solve this for us. Y is equal to 42.857. We don't know the minimum possible length of cable required. We have part of that, or we have the y value, which might help us find that. We should also find the x value that goes with it. So x is equal to 100 minus y. So x is equal to, let's get as close as I can, 57.143. So are we done? I don't think that tells us the length of cable. That just tells us that horizontal length there. What we really need to find is those lengths. So we already came up with formulas for those, so let's go ahead and use them. So length 1 is equal to the square root of 6,400 plus 57.143 squared, and length 2 is equal to the square root of 3,600 plus, did I use the wrong values? So length 1 is, yeah, okay, we're good. Plus 42.857 squared. So let's go and get approximations for those and wrap this one up. So for this first length, I'm getting 98.3. And for the second length, I'm getting 73.7. So all told, the total length is going to be, I'll just call it lowercase l here. So about 172.0 feet.